This has been a very inspiring symposium so far. Thanks to the organizers of the Center for the Art of East Asia for including me in this. I've been taking copious notes along the way for things I want to try and implement, and Aries is one of them now, so thank you for that. Just to reintroduce myself, I'm Miller Prosser. I'm from right here in Chicago, and I feel like a bit of an interloper in this symposium because I neither work in the domain of the art of East Asia nor in the museum space. My background is in Near Eastern languages and civilizations, what you can think of as the Eastern Mediterranean area, roughly period ending about 1200 BCE. But for about the last 12 years, I've also been working to apply digital solutions to data-driven research in the humanities here on campus, from problems of data integration of complex projects to data modeling of digital texts, and ultimately to the idea of a sustainable production of multimodal digital publications. There's my mouse. Come back here, little guy. And typically I work with data-driven research projects recording and publishing spatial, temporal, and textual data. And in my brief observations today, these observations reflect my current thinking on an idea that I've been pursuing recently. So in a very specific sense, I've been troubled by some trends that I've been noticing in the application of digital methods in the humanities. I'm troubled by the lack of sustainability in the choices that are available to researchers for managing and publishing data, a problem that contributes to the ever-growing digital graveyard of dead links. And I'm also concerned about the apparent lack of momentum in providing solutions to that problem. So when I think about sustainability, I think about both the back-end database tools implemented in research as well as the various modes of data publication, so how we're sharing our data. It's not a new problem. There's a rich secondary literature, now already 30 years old, pointing out the lack of sustainable digital approaches in the humanities. And by the way, if I repeat the word humanities today, I really mean the most broad possible definition of that term. I could really just say digital research of any kind. So specifically today, I will present a method for managing digital cultural heritage research in a way that makes data sustainable, durable, citable, and reusable. So as a critic of digital approaches in the humanities, my discussion today begins by acknowledging that digital tools like databases and web publication platforms, in my opinion, have not served well the interests of researchers in the humanities and related domains. And I'm not going to spend a lot of time addressing critical issues like institutional support, the costs of data preservation, or the role of research and computational professionals in the process, but these lurk just under the surface of the approach I will outline today. But strong institutional support certainly makes the type of approach that I describe possible, and I acknowledge the privilege of being here at the University of Chicago and having access to so many resources. So even though my comments will apply more broadly to all types of digital research, I'll foreground the idea of exhibition, since that's sort of what we're talking about in our gathering. Throughout the talk, I will describe an existing integrated architecture that provides researchers, museum professionals, digital librarians, and their teams with a flexible and comprehensive platform for managing cultural heritage research data from planning stages all the way through to archiving. And under the definition of publication, I would include any type of sharing of data, whether through websites or other types of digital exhibition. And beyond this idea of data publication, I will highlight some recent developments here at the University of Chicago, from developments in the digital studies area, the humanities division more broadly, and then a new exciting partnership between the Division of the Humanities and the library. Now, throughout the slides, you'll see details of this special object discovered by the Chicago Tübingen exhibition to Zincirli in Turkey. This is a beautiful dedicatory stela with an Aramaic inscription. It mentions the seated individual by name, the pronunciation of which would be something like Kutamua or Katamua. That's his name. And there's a cast of this object on display here in the ISAC Museum right here in this building, so I encourage you to go visit it, see the cast, and see a video about the discovery of this object. It's quite fascinating. So while I'm not here really to outline the life cycle of data, it's helpful to acknowledge that data curation and publication are stages in a larger process. And we've all had to wrestle with the various stages of the data life cycle. And of course, as you know, some of these steps have sub-steps, and others require iteration, going back and then forward, and it's not always a linear process. But this is at least one view of the life cycle of research data. So in the first stage, I'll only emphasize what we all basically already know, that a rigorous planning stage is critical for a digital research project. And this came up in talks yesterday afternoon, in fact. But for the purposes of my talk, I just want to emphasize the steps of curation and publication. Those will come next. I'll just mention that the planning stage is fraught with danger because just seeing it from the researcher's perspective, there can appear to be an infinite number of digital tools to implement. And I just wonder, are humanities researchers expected to become JavaScript, PHP, Python, and hardware experts? It's not really realistic. Now, I'll say, we've seen a lot of impressive technology here, so maybe the participants in this symposium are an exception because we're predisposed to using digital tools, right? But this is not yet the case for all researchers. And I always just wonder, for small research projects, even at small universities, are they expected to hire database and website specialists as contract workers on soft money? It's really precarious subject. It sometimes works, but even when it does, it tends to result in each project building bespoke digital tools that first require a lot of resources to sustain, and second, typically lack digital interoperability with other projects. So moving on to the topic of curation, here I just wish to highlight a current trend in digital humanities that I think we're going to regret when we look back in a few years. The current trend in publishing data seems to be removing the data curation stage entirely by asking us to encode our data directly in a digital publication framework. So what does that mean? In short, what I'm seeing is in the field of digital publication in academia, universities are creating tools to generate really amazing and beautiful multimodal digital publications. But the process of producing one of these publications requires the user to load their data into a content management system that was made only for the purpose of producing that digital publication, as if that content management system were a database. So in a sense, it appears to me to be blurring the difference between the publication mechanism and the database. And by loading our data directly into a single-purpose publication tool, we lose the ability to do anything else with that data. Now, I will say the creators of some of these tools have already recognized this deficiency and are working on reverse engineering their tools to make them more like a database. Of course, we could solve that problem by starting with a database that was created specifically for complex data that characterizes what we do in cultural heritage and the humanities. And that's where I'm going to start today, which brings us to the alternative approach that we implement with the OCHR database platform, the online cultural and historical research environment. In OCHR, we model research data in a highly granular and flexible database platform from which various types of publications could be produced. So instead of conflating the publication platform with the database, we maintain these two as distinct parts of the data lifecycle. In brief, OCHR is a research database platform created by researchers in the humanities. It's been tested rigorously for 2 decades now, and it's supported by a professional staff of software developers and humanities domain area experts. The database is currently being used by researchers across a broad range of disciplines, including linguistics, history, literature, ancient literature, early modern literature, and I don't know if you would call Melville modern literature, but I'll call it modern literature. It's also being used by archaeologists in North America, South America, the Middle East, Africa, Spain, and China. It's being used in anthropology, divinity, economics, historical DNA research, and even now astrophysics. So my goal today is to describe the process of digital exhibition from a database backend, and not really to provide a detailed view of Ochre and how it works, but I should mention at least a few aspects of the database that may help explain why it's useful in the context of exhibition. Then I'll also show a number of projects that are productively using the database. This is the only technical slide, and it's only meant to illustrate the system architecture, and I'm not even going to review it in detail. I'm happy to share my slides so you can read all the fine print there. In a nutshell, it just illustrates that Ochre runs on an enterprise-level database management system and provides access through a variety of mechanisms, both for viewing, analysis, and publication. And as I promised, I'm not going to dwell on this slide. We're going to move right along. Under the hood, Ochre is an XML graph database. In a graph database, data is not stored in tables that are joined by keys, as one does in a relational database system. Instead, every item is a separate database document described by metadata and integrated with other items. And this is a powerful concept for humanities data, which tends to be heterogeneous. It doesn't fit into tables, and it tends to be idiosyncratic and unpredictable. So the graph data model suits humanities research quite well. When a user logs into Ochre with their project-specific credentials, they're greeted by these high-level ontological data categories. And over the years, we've found that all research fits into one or more of these high-level categories. Spatial data finds a home in Ochre, textual data fits right in, projects can track time periods as data, and any type of image, audio, video can be integrated in powerful ways with the rest of the data. And Ochre can manage textual data of any type, Western, non-Western, alphabetic, syllabic, logographic, hieroglyphic. We've seen just about every type of writing system and language over the years. And using the database requires no computer programming skills, no installation of complex software, servers, any of that, and very little training. But support and training are provided by the Ochre Data Service here at the University of Chicago. And we're always accepting recommendations for new features as well, by the way. Projects that use Ochre can record data at any scale, so from broad geographic contexts down to specific site contexts, down even further to maybe site-wide grid systems that an archaeological project might use. And I think you can see where this is heading. We keep drilling down to specific excavation squares on an archaeological site, then even down to a specific locus, like maybe a pit or a wall, then down to the objects found in a locus, like this ceramic jug. And we're not done yet. Inside that ceramic jug, we might find a piece of charred organic material if we're lucky. So we can record metadata details about that charred organic material. And we're still not done, because many of the archaeological projects using Ochre will record the results of C14 analysis performed on part of the botanic sample. So they'll even record that as a further atomized piece of data in their hierarchy. So everything from an entire region down to a tiny sample of organic material sent off for analysis, the database can help the scholar record, curate, describe, and eventually publish that data. So returning to our Kutamua inscription, at any scale of observation, data can be described with metadata. There's not a real big difference between data and metadata in this database. They all are sort of elevated to the same level. Projects can opt to implement well-known standards for metadata in their domain area, such as maybe the Getty vocabulary or Dublin Core, or they can choose to supplement these standards with custom metadata fields as well. The point here is that Ochre is schema agnostic, as we describe it, which means that it allows for a combination of many complementary standards. So thinking about the Kutamua inscription, the Zingerle research team uses a combination of established metadata schemas and customized properties to describe the item in the database. In this case, some of the properties are shown here. As you can see, it's sort of a medium-sized object, not monumental in scale, but it's still rather a bulky piece of inscribed basalt at 99 millimeters high. As you may have gathered, Ochre is used by archaeology projects a lot, and that's actually why it was created in the first place, was to manage archaeological research data. Here, Ochre data specialist Nick Schulte manages a dozen laptops on site as excavators record data in the database as soon as it's created by the team. So in this case, no paperwork, no messy handwriting by volunteers and students, and no forgotten details. Ochre includes a robust geospatial component that allows users to view and manipulate shapefiles, points, vectors, etc. Here's a combination of drone photography, hand-drawn stone architecture, GIS shapefiles, and object photography. And all of this comes together to be integrated in one place where researchers can describe and annotate images, integrate it with their metadata and notes and other observations. The database integrates a wide range of digital files, such as georeferenced photogrammetry models generated from aerial photography, which is what we see here. I think this is 60 or 80 photographs stitched together and georeferenced. It also supports a type of photography called RTI photography. And here I am, in fact, in the basement of the Gaziantep Museum in Turkey, preparing to photograph the Kutamua inscription. It's sitting down there on that pallet jack. I'm not sure that's the best way to handle that thing, but it's quite heavy. RTI photography, I'm happy to chat about later if you're interested. In brief, it creates a single file that allows the user to change dynamically the location and properties of a virtual light source, making it easier to identify low relief features such as writing and artistic motifs. Projects often come to Ochre with a wide range of legacy data, in these cases even printed documents, and these can be scanned and annotated in the database to link to images or other items in the database, and the result is a significant upgrade to all of this old paperwork. And all of these types of annotations can be published along with the images to be viewed online. So we have a click-through ability through these annotations. And because data is modeled in Ochre in a highly granular form, it can be reused for many purposes. So here, the Persepolis Fortification Archive Project has annotated over 100,000 cuneiform signs in digital photographs, linking each of these annotations to a portion of text transcription to identify the reading of the sign. The original purpose of all that work was pedagogical, to help students become familiar with how to read cuneiform on the tablet. However, we realized that this data could be put to another use. And by extracting the annotations, we were able to train a computer to read this type of cuneiform and suggest readings sign by sign. The DeepScribe project is a collaboration between the Institute for the Study of Ancient Cultures, where you're at right now, and Digital Studies and the Computer Science Department here at the University of Chicago. And it's only because this data was modeled in a graph database that this sort of reuse of data was possible. And our first paper for the DeepScribe project has just been submitted, and we're waiting to hear our feedback from the editors. The CEDAR project pushes Ochre to a new level of text representation. This project is demonstrating that the power of comparing manuscript editions in a database environment. So here we're looking at a comparison between a medieval Hebrew manuscript and 6 fragments of Genesis from the Dead Sea Scrolls. The database identifies on a character-by-character basis, where the various manuscripts overlap, where there are differences, etc. So Oker's helping the scholars understand the variation across manuscripts and trace transmission history. So we have a wide range of tools for working with textual data, and here we're looking at a tool that aids in the reconstruction of highly broken fragments in the Dead Sea Scrolls. And in this case, researcher Sarah Yardney has identified letters on the manuscript, and later she's going to use these letter forms to suggest reconstructions for other fragments, or simply to produce letter charts. So here Sarah is testing various examples of Hebrew Aleph from this manuscript to see if this is a valid option for reconstructing this broken fragment. So she's dragged cutouts of the letter from the selection tool along the right and placed them on the image, and then she's going to test each one of them against the manuscript on the background for validity, or options anyway. The CEDAR project is using Oker also to perform a wide range of textual analysis. Here we're looking at an edition of Shakespeare's Taming of the Shrew, with various annotations locating specific phrases and other significant units identified by the team. On the right, we see a representation of the characters on the stage at this moment in the play, just for an example. The CEDAR project will be holding its annual symposium here on campus on May 22nd. For those of you in the Chicagoland area, you're certainly invited to come and attend the symposium and see what CEDAR is up to. Since 2019, the Capturing the Stars research group on the University of Chicago campus has brought together faculty, students, and staff from the Department of Astronomy and Astrophysics and the University of Chicago Library and the Department of History to study the scientific and historical legacy of the Yerkes Observatory in Wisconsin. The project is using Oker to trace these historical individuals, specifically the major role that women played in the history of the Yerkes Observatory. But the team is also performing computational calculations on historic glass plates produced over a century ago at the observatory. Now, this may not look like much, but this picture shows an image of the night sky in negative. Each black dot in this frame represents a night sky object. The team is using various types of analyses to compare this information to data in current astronomy databases. Now in the works is a multi-institutional collaboration working on the Florence Illuminated project. This project is dealing with data about the 15th century Florence tax record known as the 1427 Catasto tax assessment. In addition to the intellectual questions that arise from this data in the field of sociological, art historical, economic question, there's also a technical question about how to create a tool that can federate data from multiple sources. And that's the question that is really on the table. But what we're doing is working with various researchers at different universities and implementing Oker as at least part of that transformational process. All right, so far, I've been illustrating the capture and curation stages of data management, and I argue that these are critical steps prior to digital publication. Curation just refers to the entire spectrum of tasks just surveyed, and more, obviously. But I want to quickly move on to the publication stage of the talk. And here I wish to emphasize the thesis once again that by managing data in a robust back-end database, a project can produce not one, but essentially an infinite number of digital publications. So let's return to our friend, the Kutamua Stela. When this item, or in fact any item, is published from Oker, the database creates a web-friendly view of that item. In this case, we see a page that was auto-generated by Oker. So to be clear, this archaeological project did nothing other than click the publish button for the Katamua inscription in Oker. Now, some projects may have more ambitious ideas about what they want to do with their published data and do something more than just a catalog view, for example. To that end, data published from Oker can easily be manipulated with standard JavaScript or other web publication languages. This view demonstrates a new publication avenue we're pursuing with colleagues from the Göttingen University Library. They built this view framework for one of their projects, but that project didn't really take off. And they were really pleased to learn that the Ochre database could generate data to feed into this viewer. While we're currently in beta testing, the idea would be similar to the previous slide. A researcher would just Okay, thank you. The researcher would just click the publish button, and Ochre would generate JavaScript that would auto-populate a viewer like this. Now, in a scenario where a project does have access to a web developer, just about any interface can be created from Ochre data. In this case, our colleague John Young from the Digital Library Development Center here at the University of Chicago Library leverages Ochre data to create a language learning site where users can read and listen to audio clips of Yucatec Maya. And the rather Spartan look of this site was exactly what the scholar wanted, and so that's exactly what John did, was just use the Ochre API to create that. Any item published from Ochre is guaranteed to be persistently accessible by the same web address, so no dead links. That makes it possible to embed these types of links in print publications even. So in this case, the Leon Levy expedition to Ashkelon has embedded Ochre API links in the PDF of its excavation report. So as a reader is working through the report on this specific excavation area, they're able to click on the link for Olive Press 777 and pop up a web view showing all the metadata and related details for this press, the type of data that you couldn't reasonably publish in print. So by using these persistent IDs, every item becomes citable and durable. As already discussed, Ochre features richly integrated geospatial tools, so you can publish your data in ways that are digestible by front-end tools like ArcGIS provided by Esri. This is a sort of a multimodal publication of my own research data that gives users multiple entry points into the find spots of inscribed tablets. Clicking through lets you see details, and then ultimately you can get the full metadata details. Finally, our most recent example of a multimodal publication involves Ottoman period building inscriptions. In this JavaScript application developed by Firat Çiftçi, a graduating UChicago student, we're able to use the geolocation on a mobile phone to locate the nearest building inscription. So in this case, we're walking through Istanbul, and the app responds to our location, updating the list of nearby inscriptions, and even passing our location through to Google Maps to see the street view or get walking directions. So again, this data lives in Ochre. Person is on their phone, clicks a button, and immediately gets the most recent information from the Ochre database as they're walking around Istanbul. So to wrap up, over the last few months, I've been reflecting on the idea of infinitely recombinant multimodal digital publications. And I should put a little TM on that because I'm going to trademark that phrase. And I would certainly define exhibition as a type of publication. So just let me unpack that mouthful of words. It all begins with the semi-structured item-based XML graph database that stores each piece of data as a separate document, linking to other documents when relevant. And data is broken down into really small parts, making each small part available to be addressed separately and reused as necessary. And Ochre takes this to an extreme, making it possible to reuse and recombine data infinitely. And when we're able to reuse data, we open up a wide range of creative uses of data. So in one case, an item can partake in a catalog of objects by material, another catalog by find spot, another catalog by time period, on a map, on a timeline, in a mobile app, or whatever. So it's an infinite remixing of data. And by doing that, we can then produce a variety of multimodal publications. So I just want to close by mentioning this new exciting collaboration with the library. We're working, the humanities division is working with the library to create this thing we're calling UChicago Node as an archiving and data discovery system. The node will be a centralizing environment that makes it possible to discover data across various data sets and provide a long-term solution to the problem of the digital graveyard. And Ochre, the Ochre database platform, will be one of the initial humanities digital platforms to plug into UChicago Node. And we're very thankful that NEH funding was recently secured for this endeavor, so work is going to begin in the very near future. So just to close, to put this all in the broader context of the recent developments on campus, I'll just mention also that in a few short weeks, the university will also officially announce the launch of the Forum for Digital Culture, which will be a new unit that brings together many existing digital interests on campus and serves as the impetus for starting some new ventures as well. And one of these ventures will be the online publication service of the University of Chicago, which will provide the means and the tools for creating peer-reviewed, multimodal digital publications. That's a whole nother conversation about why that's necessary, but we do think that peer-reviewed digital publications are necessary moving forward. So while the online publication service will play a large role in what I presented today, there's a lot more I could say about online publications. That's sort of another presentation entirely. So I'll just close by saying thank you very much for your attention. It was a pleasure to be with you today. Thanks.